Hello everyone, welcome back to the chapter 8 matrices, which is the inverse of the matrices and determinant. Um, so we're gonna using the inverse matrices to finding the multiplications with the matrices inverse. Um, so if you have the power of -1, that meant to be like inverse function, inverse matrices in mathematical way. So determinant, which is where we know is AD minus BC. So what's AD minus BC means? So we have A, B, C, and D into the matrices elements. So A multiplied by D minus B multiplied by C, and that will be this determinant. So let's have a look at this determinant. How to find out the determinant? Um, Imagine we have 2 by 2 matrices. Okay, so we start with 2 by 2 matrices. Um, Let me start with 2 by 2. Um, A equal to, sorry guys, bad memories. 3, 4, 2, minus 3. Okay, 3, 4, 2, minus 3. 3, 4, 2, minus 3. So control variable, which is equal to A. And another one, so we can say it's all 2 by 2, so we do inverse. We're not gonna crazy go just reverse or inverse. So we only focus on 2 by 2. So 6, 3, 2, 2. So we have 6, 3, 2, and 2. So we do is control variable B. And then C, which is 4A36. So 4A36. So 4, 8, 3, and 6 will be control variable thing. So now we're going to try to find the many. Can you see the matrices and vertex? So we go into determinant. So if I say A, they give you A. If I say DET, you can tap that well. So we say B, they give you B. So it's just like that. So once you have the determinant, you can easily find the inverse. So let's test out the inverse. So if I say A to the power of -1, so they give you the inverse straight away. And if I say B to the power of -1, they give you that as well. So just like that, you just tap the -1, I'll give you the inverse function. Now, matrix equation, really want you guys to make sure we'll put this one in your bound reference, because in the x, so we're going to try to find x, y. So that's what we do. And you have a to the power -1b and b to the power b to the a to the -1. So just make sure you can find your unknown matrices. So if I had that, and I can substitution into the questions and to find out. So basically, if I try to find what's the x equals, so basically we can just say a to the power -1 times b, so b divided by a. Or if I say x equal to, so we say x equal to a minus 1 times 13 minus 1. So this is how you restart like the questions. So once you have the A, you just substitution, and you should be able to see the questions like that. Okay. Just like a quick go. If I say A minus 1 times B, so A to the -1 times B, times B, they give you the answer. Yeah, just like that. But it's just using the different A and B. So you can see it's all 2 by 2 matrices, and then that's how you're creating the solution. Okay, this question is pretty, it's pretty, how to say it? So can you say like we have the permutation matrices, like that one? That one? So the first thing is like you using that to multiply some matrices to equal to NORMA. So the first number become to n. Let's have a look which number is in the from matrices is it. It's the last one. Can I just say the last column you have to make sure is 1 to change to find out your answer. N is come to top. So n multiply, so 0 times 0 times r equal to 0, so which is the first one have to be 0. So and a times 0 will be 0. So you're using vertical times the horizontal. So you're using the vertical lines like that to say which one is the last one is 1, basically. So 1 times n equal to n. That's how that works. So clearly we see C is not right. So next one is O, which is this one have to be 1. So we say A is not correct. Next one, let's say R will be, the first one will be 1. So we say this one not right, but those two is correct. And now we say M is middle, which is E is correct. So we're using the simulate matrices, so eliminations matrices, to find out the actual answer. So I think now what we do is we're gonna try to figure this out, which is using the simultaneous equation to translate to the matrices. It's not unique solution means there's no unique solution, which is two lines are parallel. First thing first, that means there's no solution. That means discriminant, does determinant have to be equal to 0? So I want you guys to make sure understand that if you have simultaneous equation, it's not unique solution, determinant equal to 0. Okay, just make sure. All right, determinant equal to 0. So let's have a look. What's the determinant for this? A times B minus 4 times 18 equal to 0. So 4 times 18 equals 72. So which is A, B equal to 72, right? So once we have that 72 coming out, 72 coming out, which means the two numbers multiply equal to 72. Just figure out this. 3 times 22 is 66. It's 80 for the C, 60 for the D. That was 74. Sorry, 84. So that's not correct. So only one answer is A. Yeah. All right. Question 3. Lots of people can't understand the question 3. Sorry, cannot understand the question 3. So I'm not so sure this one. Let's have a look. First thing first, what we do have is matrix A is inverse matrix X. Why I change? Okay, because some people don't understand. Okay, we change this one again. All right, let's start with that. We're using this rule, which is a circle. Ax equal to b, x equal to a to the power minus 1 times b. All right, so we have multiplied the scalar matrix W, and for matrix is Q. So what's the Q minus 1 equals? Okay. So if I say matrix P multiplied by W, so can you say P times W? So P times W, let me just rewrite this. Okay. So P multiplied by W equal to Q. Right? Okay. So because we want to know the Q minus 1, so what's the W equals actually? I just say P minus 1 times Q. Right? So now what we do is we want to know the Q, so Q minus 1 equals. So W Q equal to P minus 1. So can I just say W multiplied by Q minus 1 equal to P minus 1? Because you under the fraction equal to to the power of minus 1. So clearly, P minus 1 equal to P minus 1 over W, which is 1 over W multiplied by P minus 1. That's algebra way, okay? Another way with substitution actual matrices. So I'm not going to do it from here. So you guys can test that. So are there any questions about this? Please email me. Otherwise, you guys are good to go for 8.5. So next one, 8.6, 8.7, and we're down for the matrices. All right, have a good one. See you guys next